For today, as for the chapter objectives, students should be able to define the advanced materials, which is ceramics, which includes ceramics and glass. Number 2, students should be able to describe and analyze the composites materials. As for the lesson objectives, at the end of the semester, students should be able to apply and explain what is ferrous and non-ferrous alloys microstructure, the strengthening mechanism and its applications, polymeric and advanced material structure, as well as properties. So today, this will be the topic content, which covers number 1, ceramic, which includes properties, categories, product, crystal structures, as well as traditional ceramic. And for glass topic, we are going to look at on its product as well as its properties. You see, in this subject, in engineering materials, these are the topics that we have covered. So today we are going to look at on ceramic and others, which includes, ceramic and glass. And you see, most ceramic materials falls into an application classification scheme that includes the following groups, like glasses, structural clay products, whitewares, refractories, abrasive cements, and newly developed advanced materials. So figure here presents a taxonomy of these several types. Some discussion is devoted to each in this lecture. Most ceramics, so let's move on to ceramics. Most ceramics are compounds between metallic and non-metallic elements for which the interatomic bonds are either totally ionic or predominantly ionic, but having some covalent character. The term ceramic comes from the Greek word, which is keramikos, which means burnt stuff, indicating that the desirable properties of these materials are normally achieved through a high temperature heat treatment process called firing. Up until the past 60 years or 60 or so years, the most important materials in this class were termed the traditional ceramics. Those for which the primary raw materials is clay were products considered to be traditional ceramics like china, porcelain, bricks, tiles, and in addition, glasses and high temperature ceramics. Of late, significant progress has been made in understanding the fundamental character of these materials and the phenomena that occur in them that are responsible for their unique properties. Consequently, a new generation of these materials has evolved, and the term ceramic has taken on much broader meaning. To one degree or another, these new materials have a dramatic effort, have a rather dramatic effect on our lives, like in electronics, computers, communication, aerospace, and a host of other industries rely on their application or in their use. These are the other examples of ceramics products which you may find in the market. And in terms of its properties or ceramic properties, ceramic have medium density, high mechanical strength, low ductility, and a very good high temperature stability as compared to other materials like metals, plastics, as well as composites. There is various types of ceramic which can be found, like traditional ceramics, where their product include pottery, bricks, abrasive, and cement. Second is new ceramic. This is considered as new invention of ceramics, which being developed based on oxide carbides, and so on and so forth. And they have a superior mechanical or physical properties as compared to traditional ceramics. The third one is glass, whereby it based a silica and distinguished by their nanocrystalline structure. And in addition, there's also glass ceramic under this category, whereby this type of glass are transformed into a largely crystalline structure by heat treatment. These are examples of product produced by ceramic. Other than that, like mentioned to you just now, like the other products for ceramic is like clay construction products such as bricks, clay pipe, and building tile. For the refractory ceramics, ceramics capable of high temperature applications such as furnace walls, crucibles, and molds. Number three is cement used in concrete, and normally it is used for construction and road. Other than that, whiteware products such as pottery, stoneware, fine china, porcelain, and other tableware based on mixtures of clay and other materials. Other than that, like bottle, glass, fiberglass, abrasive, cutting tool materials, ceramic insulator, magnetic ceramics, nuclear fuels based on uranium oxide, and bioceramics like artificial teeth and bones. And because ceramics are composed of at least two elements and offer more their crystal structure, are generally more complex than those for metals. The atomic bonding in these materials ranges from purely ionic to totally covalent. Many ceramics exhibit a combination of these two bonding types, the degree of ionic character being dependent on the electronegativities of the atoms itself. Ceramic have a superior hardness. Ceramic has a superior hardness, thermal and electrical resistance than metals. They are available in single crystal and polycrystalline. Grain size major influence on the strength and properties of ceramic. Finer the grain size, the higher strength and toughness of that ceramic. Ceramic also have its own imperfection. For example, vacancies, displaced atoms, interstitials, and microscopic cracks. So, in ceramic, there are internal flaws which tends to concentrate stress, especially tensile, bending, or impact. And due to that reason, ceramic will fail by brittle fracture. So as overall, the performance of ceramic is unpredictable due to its random imperfections and processing variations. In traditional ceramics, it's actually referring to ceramic materials that are derived from common, naturally occurring raw materials such as clay materials and quartz sands. Through industrial processes that have been practiced in some form of centuries, these materials are made into such familiar products as china tableware, clay brick and tile, industrial abrasive and refractory linings, and Portland cements. Traditional ceramic objects also are almost as old as the human race. Naturally occurring abrasives were definitely used to sharpen primitive wood and stone tools, and fragments of useful clay vessel have been found dating from the Neolithic period for some like 10,000 years ago. Not long after the first crude clay vessels were made, people learned how to make them stronger, harder, and less permeable to fluids by burning. These advances were followed by structural clay products, including brick and tile. Clay-based bricks, strengthened and toughened with fibers such as straw, were among the earliest composite materials. Artistic uses of pottery also achieved a high degree of sophistication, especially in China, Middle East, and Americas. Because of the large volumes of product involved, traditional ceramics tend to be manufactured from naturally occurring raw materials. In most cases, these materials are silicates, that is, compounds based on silica, SiO2, and oxide form of the element silicon. In fact, so common is the use of silicate materials that traditional ceramics are often referred to as silicate ceramics, and their manufacture is often called the silicate industry. Many of the silicate materials are actually unmodified or chemically modified. aluminosilicates. Although silica is also used in a pure form. Altogether, the raw materials employed in traditional ceramics fall into three commonly recognized groups, such as clay, silica, and feldspar. Now let's look at on glass. Well, glass is an organic solid material that is usually transparent or translucent, as well as hard, brittle, and impervious to the natural elements. Glass has been made into practical and decorative objects since ancient times, and it is still very important in applications as disparate as building, construction, houseware, telecommunications. It is made by cooling molten ingredients such as silica and silica sand with sufficient rapidity to prevent the formation of visible crystals. Why so much silica in glass? Well, it is because silica is the best glass former, and silica is the main component in glass product. Usually, it consists of 50% to 75% of total chemistry, and it naturally transforms into glassy state upon cooling from the liquid, whereas most ceramics crystallize upon solidification. Other ingredients in glass includes sodium oxide, calcium oxide, aluminum oxide, magnesium oxide, potassium oxide, lead oxide, and boron oxide. And their functions is actually stated such as follows, like act as a flux during heating, to increase fluidity in molten glass for processing, improve chemical resistance, add color to the glass, and alter index of refraction for optical applications. Examples of glass product includes window glass, containers, light bulbs, laboratory glassware, fiberglass, optical glasses, and so on and so forth. As for the physical properties for glass, for example, density. In general, ceramics are lighter than metals and heavier than polymers. Some ceramics are translucent, which window glass being the clearest example. Melting temperature, which is higher than most metals. Some ceramics decompose rather than melt. And electrical conductivities, lower than metal, but the range of values is greater. For some ceramics are insulator, while others are conductors. As for the thermal properties, includes number one is the thermal conductivity, such as it has lower thermal conductivities as compared to metals. Due to their strong ionic covalent bonding, ceramic materials are used as refractories, which resist the action of hot environment, both liquid and gases. And number two, it has a thermal expansion, somewhat less than metal, but effects are more damaging because of brittleness. As for the mechanical properties for glass includes, theoretically, the strength of ceramics should be higher than metals because their covalent and ionic bonding types are stronger than metallic bonding. However, metallic bonding allows for slip, the basic mechanism by which metals deform plastically when subjected to higher stresses. Bonding in ceramic is more rigid and does not permit slip under stress. That's why we call it as a brittle. And the inability to slip makes it more difficult for ceramic to absorb stresses. So that's why we call it as a brittle. So I think that will be all for today's topic. And we are already finished with chapter 8. And as usual, if you do have any questions related to the topic, then you can refer it to me either in Google Classroom or WhatsApp group. With that, thank you very much and see you again in the next class. Okay, have a nice day. Bye.